This video will explain how to find the coordinates of a point on the unit circle, given the angle. Remember that a reference angle is the size of the smallest acute angle, notated by t to the r, formed by the terminal side of the angle t and the horizontal or x-axis. Also remember the unit circle, shown here. The blue lines coming off of it show different angles on the unit circle. Finally, remember the basic trig functions, which are sine, which is the opposite over the hypotenuse, cosine, which is the adjacent over the hypotenuse, and tangent, which is the opposite over the adjacent. These three trig functions are crucial to find the coordinates. First, we start with 155 degrees, shown below on the unit circle. We can drop lines off of the angle, which is shown right here, and to form a right triangle. We can use the reference angle of 25 degrees to find the coordinates. The coordinates are x, y, which also mean cosine, which is x, and sine, which is y. Y is shown right here, and x is right here. Since the degrees of a triangle add up to 180 degrees, we know that the other angle on this triangle is 65 degrees. The hypotenuse is 1 because the unit circle has a radius of 1. So first we can take the sine of this triangle, or 25 degrees, and remember that sine is the opposite over the hypotenuse, so y over 1, which is just equal to y. Sine of 25 degrees equals y, and when you punch that in your calculator, you get that y is equal to 0.423. Remember to have your calculator in degrees, otherwise you will get the wrong answer. Now we can do the same thing for cosine. So we go back over here to our triangle, and we can see that cosine of 25 degrees is going to be x over 1, because cosine is the adjacent over the hypotenuse. So cosine of 25 degrees is equal to x over 1, which is just equal to x. So cosine of 25 degrees is equal to x, and x is equal to 0.906. But we have to remember that this is going to be negative because it is in quadrant 2 and cosine is negative in quadrant 2. So for 155 degrees, we get that it is equal to negative 0.906, 0.423. Next, we can move on to negative 155 degrees, which is shown here in a third quadrant. Here's the angle. Here are our points that we're trying to find. We can drop our lines to form this 90-degree right triangle. This is going to be our side y, this is side x, hypotenuse of 1. Other angle is going to be 65 degrees. And we're using this reference angle because that is the one closest to the x-axis. And if we try to put negative 155 degrees in here, that would include this whole thing, which is not a triangle. So we just have to find back to the x-axis. And that way we can set up the whole thing and use trigonometry to solve for the coordinates of the point. So we look at sine, which is going to be our opposite over the hypotenuse. Y over 1 is equal to y. So sine is going to be 0.423, but we have to remember that this is going to be negative since it is in quadrant 3, and sine is negative in quadrant 3. We can do the same thing for cosine. It's just going to be the adjacent, which is x over 1. So x over 1 is just equal to x. So x is going to be equal to 0.906. And again, this is negative because it is in quadrant 3. So for negative 155 degrees, we get that the coordinate points are negative 0.906 and negative 0.423. Next, we move on to negative 25 degrees, shown here in the fourth quadrant. And for this one, we can use 25 degrees because the reference angle is still 25 degrees back to the x-axis. It's just going to be positive still. We drop our lines. So this is the angle. We drop the lines here to form this right triangle with y and x, point xy, cosine, and sine. So first, we're going to look at our sine, which is y, the opposite over the hypotenuse, y over 1. Sine of 25 degrees is going to be equal to 0.423, which is going to be negative because it's in the fourth quadrant. Then we look at the cosine, which is going to be, again, the eighth adjacent over the hypotenuse. So that's going to be x over 1, which is just going to be equal to x. And x is going to be equal to 0.906. And cosine is positive in the fourth quadrant. So negative 25 degrees is equal to 0.906, negative 0.423. Last angle, we move on to 335 degrees, shown again here in the fourth quadrant. And we can't use 335 degrees because that would be this whole angle right here, and it wouldn't form a triangle. So we have to use the 25-degree reference angle here. That is crucial. And since it all adds up to 180 degrees, we know that this angle is 65 degrees. The point xy here, you use sine of 25 degrees, which is equal to y over 1, which is just simply y. Sine of 25 degrees is 0.423. And again, it's negative because it's in the fourth quadrant. Lastly, we move on to cosine, which is, again, just going to be x over 1. Let me write that here. X, 1, y. Okay, and then we have x over 1, which is equal to x. So x is equal to 0.906 when you punch that into a calculator. So for our final answer, 335 degrees is equal to 0.906, negative 0.423. So our key concept here is that the unit circle, or really any circle if you know the radius, plus your angle, plus your trig functions, and you can find the coordinates on the unit circle. So you can use your trig functions to systematically determine the sides of a triangle on the circle. So you get the coordinates of a point. By dropping the sides to form a right triangle, you can use sine and cosine to systematically figure out what the sides are.